So the first problem we have is Dennis is a swimmer that swims the length of the pool, which is 40 meters, and he does that in about 10 seconds. So we always want to draw a picture. This time I put a picture in there, and I'm showing that he swam 40 meters there in 10 seconds. Then it says that he swam back immediately, which is another 40 meters, so he swam down and back, and when he swam back, he did that in 15 seconds. And so the question is, what is his average speed? Well, remember that the speed is going to be the total distance traveled over the total time. So the total distance is the 40 meters down plus the 40 meters back over 10 seconds down plus 15 seconds back. So you get 80 meters over 25 seconds. If you take the top number 80 and divide it by 25, you get that his speed was 3.2 meters per second. Okay? Now that's different than velocity. Velocity would be displacement over time. So then the displacement would have been 0. Now for the next one, we're told that somebody walks 31 steps in the east direction. And so remember that we have never eat shredded wheat, or north, east, south, and west. So 31 steps in the east direction. Then they walk 16 steps in the south direction. So I'm going to draw my picture, 31 steps due east. Then from that point, they walk 16 steps due south. Okay? And then the final question is, what is their displacement if an average step is 0.82 meters? Well, your displacement is your starting point A to starting point B. So what I really need to figure out is the distance from A to B. Well, that's easy to find. If I use the Pythagorean theorem, I can find the hypotenuse of this right angle triangle, which should be equal to the square root of 31 squared plus 16 squared. So remember that these are the steps, and at some point we're going to have to convert that to meters. Now, if you choose to, you can convert 31 steps to meters and 16 steps to meters. That's fine. You'll get the right answer either way. So what Mr. Adams chose to do is I did the steps first. So I'm going to keep everything steps, and then when I get to the end, I'll convert everything over to meters. Perfectly legitimate. It'll be fine. So what I'm going to do now then is 31 squared is actually equal to, let me plug this in here, 961 plus 16 squared, which is 256. If you add those up, I need to find the square root of 1217. The square root of that is about 34.88 steps. Now, I gotta keep in mind that that's 34.88 steps. So if I were to walk straight from A to B, it would take me about 34.88 steps. But like I said before, I need to convert that to meters. So one step is equal to 0.82 meters. So now we need to convert that. So I'm going to say 34.88 steps over 1 times, I'm going to put the steps on the bottom for my conversion factor and the 0.82 meters on the top. I did that so that the steps units cancel out. And so if I take 34.88 and multiply it by 0.82, I get about 29 meters. It's like 28.6, but if we round it up, it's 29 meters. Well, we were asked for displacement. 29 meters is the approximate magnitude, but remember, displacement is a vector. So if displacement is a vector, then that means it has a magnitude and it has a direction. The 29 meters is just the magnitude. We need to figure out what the direction is. Essentially, what we need to do is find the angle that we traveled from point A to B. Well, let me make a little space over here. We'll get our compass out of the way. Essentially, what I need to do is, this is a right angle triangle, and we can always use our trigonometric ratios to figure out what the angle is. So to find the angle, I need two sides. I noticed that the given information, 31 steps, was the adjacent. and that the 16 steps was the opposite. Tangent is opposite over adjacent, so if I take the inverse of the opposite over the adjacent, that will give me the angle. So I take the inverse of tangents of 16 over 31. If your calculator's in degree mode, it spits out 27 degrees. Now remember, we're sweeping 27 degrees south of due east. So we could write that 27 degrees south of east. Remember that 29 meters is our magnitude, and the direction is going to be 27 degrees south of east. Okay? So displacement is a vector. It has a magnitude and a direction. Next question. A car is traveling at 60 kilometers per hour. Remember that 60 kilometers is the same as 60 times 1,000 meters, and that 1 hour is equal to 3,600 seconds. So to convert kilometers per hour, 60 kilometers per hour is about 16.67 meters per second. Again, it reaches a speed after it accelerates up to 90 kilometers per hour, which is going to be 90,000 over 3,600, which reduces down to 25 meters per second. I did that right off the bat because we always want our velocities to be in 25 meters per second. So the question goes, a car starts at 60 kilometers per hour, accelerates at a rate of 4 meters per second, and ends up at a final velocity of 90 kilometers per hour. So to recap that in SI units, we start with an initial velocity of 16.6 meters per second, go up to 25 meters per second for my final velocity because we accelerated at a constant rate of 0.4 meters per second. The question they ask us is, how long does it take? The time. So consider the kinematic equation. Final velocity equals initial velocity plus the acceleration times time. Notice that I have 3 of the 4 variables listed. That's a good equation to use. So it's plug and chug. I plug in all my numbers that I know. I'm left with one variable t. Algebraically, I just solve for t. So I subtract subtract 16.67 from both sides. Then I isolate the t by dividing both sides by 4. And I get about 2.08 seconds is about how long it would take me to do that. So it would take me about 2.08 seconds to go from 60 kilometers per hour to 90 kilometers per hour, or 16.67 meters per second to 25 meters per second with an acceleration of 4 meters per second. However, I want to point out that all the information they gave me was in 2 sig figs. The 60 was 2 sig figs, the 90 was 2 sig figs, and the acceleration was 4.0, which was 2 sig figs. So I might want to consider making my answer 2 sig figs, which would be 2.1.